Hi guys. So this video, I'm just going to go through TUM Fonts essentially, and the real thing I want to go through is how you can do reference counting to keep track of the uses of objects. I'll explain a bit what this means in a second, so that you don't accidentally free memory that is being used somewhere else in another task. Because as you can imagine, this is a problem. Now, where this happens is that, as I was explaining with this sort of simultaneous reading and writing, that you get really weird behavior, and it can be undefined and it crashes. Now, this reading and writing is the problem. As you can imagine, I went through the example of where two tasks are trying to read an increment and then store a variable, and because of how they did it without locking and without atomic operations, the variable's value was not correct at the end of it, and therefore we can say that we have corrupt data. Now, it becomes a bit different when you start talking about multiple tasks just reading a value. So like, if you can imagine, if no one's updating the value, all tasks are quite easily to read this value at the same time. Now, they're obviously not going to be, depending on like the bus architecture and the underlying hardware, I'm not sure, but I'm pretty sure they won't be reading it in the same clock cycle, but essentially in the same sort of logical code cycle, whatever, they'll be reading the same value, and therefore if it's all the same value, it's all valid and it's fine. But the problem is that if you have two tasks that have this value, that they're reading it, and most importantly, what I'm talking about here is if it's just some integer value that you have, it's probably not the biggest problem because you've probably just taken a copy of it or something. But I'm generally talking now about C when we're using a pointer to some sort of an object, like a larger structure in memory that's a bit more. That's probably going to sit one place in memory, and different tasks are going to take a pointer reference to it. They're not actually going to take a copy of the entire structure. So each task will have some pointer, some reference, and I'm going to say reference here because really what the pointer is doing is referencing the location in memory. And so these tasks have references to this object. And generally, like when you have, in this fonts case, I'm using the SDL2's TTF font like backend to manage the fonts. And how it works is you have to load a TTF font file into memory, you give it a size, and you essentially create this font object, which is part of the TTF library. And then this is the object. You have to then use this object when you're using their string printing functions. Like you say, yep, load this string and print, load this font and print this string. And so now the problem is that if two tasks are using the same instance of this font, we need to make sure that when one task is finished with the font, it doesn't just close this, it doesn't delete the font, because the other task is still using a reference to this object in memory. And so as you can imagine, this is a problem that you need to somehow track which task or how many different processes on your computer actually still have an active reference to this object, meaning that they, in their stacks, their task stacks, they have a pointer that points to this location in memory. They haven't freed it yet, or they haven't said, I don't need to use this font object anymore. And so this is a pretty active problem. And we'll see, like for instance, in the Linux kernel, a lot of objects have the same thing. Like a lot of different processes can read things at the same time, and essentially when they open something, they actually what you have is that this object has a reference count. And we'll see this. Hopefully, I can find it in the documentation somewhere. I think it's actually in the. If I put it in the C file. TUM font ref, right? And so we'll see that my font, I haven't documented this yet, sorry. You shouldn't really need it because you access through the API. But essentially each font object in my TUM font library is structured in a way such that I have the path. So like this is the complete system path that I use for actually opening the font file, the name of it. And so this is what we're using when we just want to say load this font, which has this name, because this is for us, it's sort of like the human readable way of accessing the font. This is this other structure called TUM font ref, and this is where I store the font itself and the reference count to the object. We have the size of the font, which is like when you load the font, you say the size of it, and then this is next. So I store these fonts in a linked list. which I don't think I'll really go into. If you're really interested in linked lists, definitely Google it. It's a very useful data structure for providing code, like extremely useful. I use it a lot. And so anyway, we'll look at this structure here, and we'll see all it does here is it has, this is the TTF font pointer, is part of the STL2's TTF font library. And so this is not my thing, but this is this is a reference to the loaded object in memory. Like I call TTF font open or whatever it is, and it will load the font from file and create this reference. It will make this pointer valid that I can then go and call these STL2 font library calls using this font. But so then the ref count is there because multiple tasks might be using the same font to print strings at the same time. And because of how the TUM draw library works, which I sort of touched on, in that you have this frame swapping, and between when the frames are swapped, these draw tasks create work packets. So they essentially create a little structure in it which says what needs to be done. And in the case of a drawing, and then these work packets are put into a queue, and when this swap buffers task is called, all of this queue is executed. So as you can imagine, between these swap buffers task calls, this work queue contains a lot of work packets with data in it, just waiting for this next call. Now the calls to the draw text ones, they store a reference to the font that's going to be used for that draw task. So between these swap buffers tasks, they need to have a valid reference to this font object, because this font object needs to still be there when this buffer swapping happens and the actual string drawing happens, right? And so therefore I need to store a reference count, meaning that if any code wants to actually free this object or close this object that the STL library is opened, it can't, because it says, hey, somewhere else on this system, someone is using this font. And so that's what ref count does. Essentially, if we look into, I'm just going to open another window, graphics. Now, where did I do this? Ref count. So this function call here, and if we look at the documentation for this one, we'll go to files, tumfont.h. So this that should be wrong. Retrieves, I'll fix that, a reference to the current STL2 TTF font, increasing the reference count to the respective TUM font, and then objects cannot be freed until all references have been put. And so this is the whole idea of this thing, is that this reference count, when you're taking a reference to it, you are in the background increasing this reference count, and you have to then you have to essentially say, I'm done with this reference, I don't need it anymore. And so that's why, and that's when you use this TUM put font. And as we can see in the drawing library, so if we go into TUM draw and we look for put font, we'll see this is the background, this is the final call that actually instruments the drawing of a string to the STL library. Essentially here, this font is passed in, this is this reference, and then once I'm done with it, I put it back. So this is the moment when I'm saying this work packet, this drawing work packet is finished with this font's reference, and this will decrement the font, the reference count. And so if we go back to this guy, we'll also see this pending free. Now what a pending free is it saying someone has tried to free this this structure, but and a pending free will get set if the reference count is non-zero. So it's saying someone tried to free this, but someone else had a reference to it, meaning if you free it, then this reference becomes invalid and you'll get a memory error when this other task tries to access this reference because it's already been freed somewhere else. And so this is a very easy way, and in this case, the font library uses it. How I implemented it was that I said, if you change the font size, you essentially create a new instance of the font with a larger size, and you try and delete the old one, but you only delete it if no one's got a reference to it. If someone else is referencing it, like let's imagine you draw 3 things using the old font, you make the font bigger, and then you draw some new things, until those three things with the smaller font size have actually been drawn, you won't free it. But as soon as they've been drawn, the reference count will go back to 0, and then the background font stuff will see, hey, pending free was set. Now we have a reference count of 0. Now it's safe to free this font, right? And so hopefully that makes sense to people. And so then I'm going to, by hopefully understanding how that works, I'll then go to the code that I put in the demo, like into the demo commit, like with the main.c modifications, to see sort of how this getting a reference and putting a reference works, right? So we've seen that there. I don't think we'll need more than that. And so now if we go to GitHub and we'll look at these commits, we'll see this is the commit from the pull request contained these two commits, and I put in here all of the modifications to main. And so looking at this changes here, we can see that what we've done is like in this example, what I want to do is, or how the TUM font library works is that you have this like a current active font, which is like this default font, and you can change the size, and then this default font becomes larger, you draw something, and then if you want, you restore this default font. So you have one active font that gets used when you make a call to draw string, and then the current active font gets attached to that draw string work packet that's created. So you can't actually have multiple fonts active at the one time. You always have one active font, but you can essentially switch before you make a draw string call, which is the active font. So you just have to make sure that the font you want is active before you make a call to draw string. And so in this case, when I'm drawing this this string here, this quit change state string, I wanted to print it bigger. So I'm setting the active font size to 30. But what I wanted to do is I wanted to restore the previous font size, because the default font size is 15. And so what I'm doing here is I'm getting the current font size using TUM font get current font size. Then I'm setting the font size to 30. So I'm creating, in the back end, I'm creating a copy of this font object, and then with the increased size. And then at the end, I'm saying, yep, I'm done with it. Will restore the previous font size to the active font. Now this is not saying, yes, put the reference, because this call to TUM draw text has created a work packet with a reference to the current font, like this active font with the size 30. And so until that is drawn, this guy will exist in memory, like it'll exist in the back end. But so I'm gonna quickly, not full screen, we'll go back here. Now I just recorded this cherry picking thing, and I think if I look at git diff, I'll have this include, so I'm just gonna stash that, and then I'm just gonna pull master, because this should get me all of the changes. Yes, no, thank you. And so now if I go to my build here, make, this should give me the example, which we'll see here what this is doing. Couldn't open message queue. Okay. This might be a result of my implementation stuff I was doing yesterday, that these message queues are hanging on my system. As I was mentioning in one of my lectures, it's really important to have like cleanup code, because in Lash Dev message queue, I have these message queues open. Now the solution to doing this is to change my main and to change the names of them. So I'm going to quickly do this, and we'll just make you guys like, just get rid of this actually. Okay, this is a problem. Before I recorded some videos, and in the middle of demonstrating the fonts thing, it crashed, which is how it always is. You test it, you ask someone to review it and test it for you, it works, and then you go to use it on like a screen record, and of course it crashes. So it's been fixed now. I just wanted to say that if you go through this video and you're following this updating, that the commit IDs are now different. The commit messages look slightly different. I added in this guy here, which remedies the solutions, the problem before, but these guys should still be the same. But the merge request has just changed. So things look a little different, but everything should still be the same. So hopefully it's not too embarrassing. Yeah. Anyway, thank you for watching the video. Okay, so now, sorry, I added it back. If we run the code again, we'll see that this string here is big, right? As it should be. And it's restored the small font because it was drawing. If you go through the main, you'll see that it draws the button fonts with this normal size, this previous size. You then set the font size to 30, and then you draw you draw this text, and then you go back to the old font size. Now, the second example that I implemented in the demo code was you can also get a font reference by handle, and what a handle is essentially an instance of the font, meaning the font itself, like the font name, and the size, because here I'm essentially just changing the size but not changing the font itself, and here I'm actually changing the font completely. And so I have this FPS font define, which is this guy here. So I'm using this IBM Plex Sans Bold, and I'm saying here, get me the current font. So I'm getting a font handle, and using a call to this of the current font. Then I'm selecting the font, and so we'll see I've loaded it already in my main this is in my main function. I've loaded the font because I need to load it into memory, and then I can select the font, and then and so what I'm doing here is I'm essentially creating another object in memory of this like font instance. And then in here, he'll create a reference to this object. And so because I've then used a reference, or I've created this guy here, I need to then I've created the handle here. I need to say, yeah, put the font handle back, which means get rid of this reference, because this font handle actually creates a reference to this font as well. Not just the work packet creates a reference to it, but any time that you have some data, anything that has a reference to this object in memory, it creates a reference, it increments the reference count. And so what I'm doing here is I'm putting back this reference count. So I'm restoring the font using the handle, so select font from handle, and then I'm putting back this the reference count, right? So hopefully that makes sense to everyone. We're going to debug and test this stuff a bit, but hopefully I've just sort of explained this concept. It's a bit of an advanced concept. It's not something you necessarily need to do, but I implemented it yesterday and thought, hey, yeah, cool, this might be an interesting little fun fact session to share with the students. So anyway, thank you for watching if you have watched, and I hope this at least helps you know how roughly to use TUM font. Everything should be documented in the documentation. It's very straightforward. There's really only a couple of functions. If you read through these, it should explain it. A lot of them you won't need. You'll mostly just need to load the font, select the font that you want to use for a certain call. You can also select the font size, and then all the rest of these sort of things are used for if you wanted to like swap back. But you can also just use recursive calls, or just use recurring calls to like setting the size. You don't have to save the old size and restore it. You can just say set to 15, set to 30, set to 15, set to 30. Okay, thank you for watching.